Right. For the last set of videos, what we're just gonna think is, wouldn't it be nice if instead of always doing the limit definition of the derivative, wouldn't it be nice if we had certain formulas? And there are, and what we're gonna talk about is differentiation rules. Okay, it's not a tacit what do you call this? It's not a tacit encouragement or like endorsement of differentiation rules. No, no, no. What we're gonna talk about are, given certain functions, how do we find the derivative easily? All right. Okay. The first is the first rule is the constant function. Okay. That is, what is the derivative of a constant function? Okay. Where c is a constant. In this particular example, it's not a hardship. The derivative of c is always 0. Okay? No matter what the constant is. Does it make sense? In in this sense, for example, the derivative of say 2, the derivative of say the number 2 is equal to 0. The derivative of pi is 0. The derivative of negative square root of e, just as an example, this is equal to 0. As long as this is a constant, the derivative is 0. Okay? Now, as a as an exercise, as seat work, I guess, one, verify this using the limit definition. Verify that the derivative of a constant is 0 using the limit function, the limit definition of the derivative. Okay? Making sense so far. Now, what if we have a function that looks like this? F of x is equal to x squared, for example. How do we find the derivative of that? Okay, we can do that the limit definition. It's not hard, but what we're gonna do is something called rule number 2, the power rule. Okay, what is the power rule? The derivative of x to the n. So let n be any number. Okay, n is any number. N is can be anything. The derivative of x to the n will be n times x to the n minus 1. Okay, or if we visualize that, x to the n, we put this to the front, we yeet it to the front. Then, since that we got one exponent out, we're just going to subtract one at the exponent. So we yeet it to the front. Then the n here, since that we got the one and put it in the front, it'll just be n minus 1. Okay? So for example, this one right here, then its derivative, f prime of x, will be, we put this to the front, 2x, then it's 2 minus 1. All right? In this particular case, n is equal to 2, or just 2x. So the derivative of x squared is 2x. Okay? So example 2. What is the derivative of x to the fourth? The answer is, of course, we put this 4 to the front, then we subtract 1 from the exponent, 3. What's the derivative of x to the seventh? It's 7x to the 6. Okay? We put in front, we subtract 1. How about 1? How about the derivative of x? Okay? Well, this is equal to the derivative of x to the first. Then this will be equal to the derivative. What we do is we put this 1 to the front. 1x, we subtract 1 to 0. Or x to the 0 is just 1, so this is just 1. So meaning the derivative of x is just 1. Okay? Another. What's the derivative of, say, 1 over x? Now, for this particular example, it seems hard to do so. But what we do is, we rewrite this into, instead of 1 over x, we rewrite that as x to the negative 1. And we can then implement the power rule. This becomes negative 1 times x to the negative 1 minus 1. It is negative x to negative 2. Or negative 1 over x squared. Okay? How about this? How about the derivative of, say, square root of x? Now, it may seem unobvious, but we can rewrite this as the derivative of x to the 1/2. Then, of course, we do the power rule again. Because again, n it can be any number. Fraction, it can be anything. So, we put it to the front. Then, this is 1/2 minus 1. Or 1/2 x to the negative 1/2. Or 1 over 2 square root of x. Okay? Right. Now that kind of makes sense. So we started with a constant function. We then went the power rule, right? The next rule, okay, is what we call the constant multiple. So, for example, let C, let, yeah, I guess, let C be any constant. Okay? Or be any number. Then the derivative of C times any function f of x, okay? So the derivative of C times f of x is just equal to C times the derivative of f of x. Meaning, you can eat the multiple, the constant multiple outside. Okay, that's it. So, for example, example 4, the derivative of 3x to the fourth, for example. So this is equal to 3 times the derivative of x to the fourth, which is equal to 3 times 4x cubed, which is equal to 12x cubed. Notice there's a bit of shortcut when you have something like this. When you do, you can try to do the power rule here. So you put the 4 here, right? But there's a 3 already. So what do? You multiply 3 and 4 to get 12. Then, of course, the power rule is the same. You get one exponent, so it becomes 3. Another example. What's the derivative of 6x? Okay. Now, you can do the power rule, whatever. So, but with the constant multiple rule, it's this, right? We can yeet the 6 outside. Then this right here is equal to 1. So 6. So, in reality, there's a little bit of a realization here. The derivative of any number of the form c times x, where c is a constant, will always just be c. Okay? How about the derivative of 12x to the negative 5? Okay? That's just 12 times the derivative of x to the negative 5. This is just 12 times negative 5 x to the negative 5 minus 1 is negative 5 minus 1 is equal to negative 6. Right? Negative 5 minus 1 is equal to negative 6. So this will be negative 6 or negative 60 x to negative 6. Of course, you can rewrite this as negative 60 over x to the 6. All these are equal. These are both equal. All right? So that's the constant multiple rule, meaning you can yeet the constant multiple outside. The next rule is called the sum and difference rule. There's a little bit of a chiasmus here. It will be that the derivative of a sum or a difference, so this is a plus minus sign, so it's either a plus or a minus, is equal to the sum. So the derivative of a sum is equal to the sum of their derivatives. Okay? The derivative of a sum or difference is the sum of their derivatives. Okay. So for example, I don't know what example this is. What number example? Example 5. What's the derivative of x cubed plus x squared plus x? Okay. This will just be the derivative of x cubed plus the derivative of x squared plus the derivative of x. This will all be equal to 3x squared plus 2x plus 1. So the derivative of this in expression right here is this. That's not such a hardship. This one, it's also not such a hardship. Derivative of 5x to the fifth minus the derivative of 4x to the fourth. Okay. Which is equal to 25x to the fourth minus 16x cubed. All right. But in actuality, you can mentally skip this intermediary step by just imagining where that you're distributing the derivative operator to both of these expressions so that you go from here to here quite easily. All right. Sum and difference. Now, uh, let's try some uh, derivatives right here. Right. What is the derivative of 1/2 x minus 1/3? Okay. Now, if you see a constant there, that means that its derivative is 0. Okay. So this is just the derivative of 1/2 x minus the derivative of 1/3, which is equal to 1/2 because the derivative of this is 0. Okay. What's the derivative with respect to t of 5t minus 9t squared? Okay. Again, you can imagine that this happens. So this becomes 5 minus the derivative of this expression right here is 18t. Right. Uh, the derivative of x plus square root of x. Right? Again, okay. Ideally, sana you're pausing when once I say the item, but m of square root of x, which is equal to 1 plus. Again, you can rewrite this as the derivative of x to the 1/2. Okay. So this becomes 1 half x to the negative 1 half, right? So I can accept this, but the more correct answer would be 1 plus 1 half 1 over 2 square root of x, right? Ah, there it is. What's the derivative of the cube root of x plus the fourth root of x, right? Now, okay, try it out. Answer in 5, 4, 3, 2, 1. Notice again that cube root of x is x to the 1/3, and fourth root of x is x to the 1/4. So you can rewrite the problem into something more manageable, so that this becomes the derivative of x to the 1/3 plus the derivative of x to the 1/4. Then we find the derivative accordingly using the product spoiler for the next video. Using the power rule, so that this is 1/3 x to the 1/3 minus 1 plus 1/4 x to the 1/4 minus 1. Or, if we simplify this, this is 1/3 x to the negative 2/3 plus 1/4 x to the negative 3/4. Okay? Negative 3 over 4. Right? And last item. All right. So, find the derivative of 186.5 plus the cube root of the square root of e all over 4 pi squared minus 5e to the 7th. All right. The answer in 5, 4, 3. The answer is 0. Why? There is no x in the expression. Hence, it is a constant. If you read the expression clearly, there's no x variable. Sir, why x? Why x? This is why. Whatever that variable is, that's your focus for the differentiation. That's the reason why we focus here on t, right? Then we derive using t, okay? But of course, if these are different, so if this is x and there's no x in here, that means this is just a constant, right? So for this video, we discussed 4 rules: the constant function, the power rule, the constant multiple, and the sum and difference. Okay? See you in the next video. Bye for now.